But we're going to look at a list problem now where the km isn't a constant value, and when it isn't a constant value we have to use the hydrostatic particulars and potentially do a bit of interpolation, which we'll go through as we go through the problem. So in this problem here, our vessel is at a true mean draft of 4.2, salt water, kg9. We're going to load a 60-ton boiler with our own derrick. The head's 30 metres above the keel, and the boiler, it's on a railway truck that it's to be lifted from, and it's 16 metres from the centre line of the vessel. So we need to calculate the maximum angle of heel in part A. Well, the maximum angle is obviously going to occur when the derrick first picks the boiler up at a distance of 16 metres from the centre line. When we calculate the angle of heel, or angle of list we should really call it, I guess, tan theta GGH over GM. GM of course is km minus kg, so we need to find our kg. We use the tables, and we're not told our displacement, but we're told our draft is 4.2. So we go into the hydrostatic particulars at 4.2, look for the salt water value, and that's our initial displacement. So here's our hydrostatic particulars, find 4.2, and there's our, in salt water, our initial displacement. So we put that in, 8336, our initial kg is 9, vertical moments, we're loading a 60-ton boiler. Obviously the kg of the boiler has got to be the height of the derrick head, and it will remain in that position until the weight is actually off the derrick. So there's 30 vertical moments. Moments divided by weight gives us the final kg. The km we have to find from the tables. We then subtract the kg from that, and that gives us a gm. Now in this problem it tells us the km from the tables is 9.68. And we have to find the km at 8396, which is the displacement at that time. We don't use the initial displacement, we use the displacement when it's picked the weight up. So when we look at the hydrostatics, we have to find the two values of displacement that fall either side of 8396. And it's 8336, 8552. Be careful that you use the saltwater values. If we're in saltwater, obviously if we're in freshwater, we'd use the freshwater values. So 8336, 8352, we go across and we read off the two km values. So we can see there the km transverse, go down, and we can see the values of 9.71 and 9.60. So I've written them here, 8336, 8352, 9.71, 9.60, and that's the value we're trying to find. Well, before we do the interpolation, it must fall between those two values. It must fall between 9.6 and 9.71. If you calculate it mathematically and are outside those parameters, you've done something wrong. There's different ways to interpolate. I'll just show you the way I use. I get the difference between my two values from the hydrostatics, 8336, 8552, sorry, and I put those on the bottom of these two values. That's 216 on the bottom. Then I go 8336 to 8396, gives me 60. 8336 gives me 60, and then I multiply that by the difference between these two, 0.11. So it's 60 over 216 times 0.11, gives me 0.03. Because I've gone from 8336 to 8396, I must apply this correction that way as well. So it's got to be 9.71 minus 0.03, 9.68. You could have interpolated down. You could have gone from 8552 to 8396, put that on the top, and then whatever value you got, which would have probably been 0.08, you then have to come down with that value. So you can interpolate either way. There's no right or wrong way. Whichever way you feel logically suits you. So we've got our km, and that's what we always do, interpolate to get our km from the tables. And of course, once we've got that, we work out our GGH, so it's 16 metres off the centre line, listing moment 960 over 8396, and then we get tan theta and the angle of 12.2 degrees. So how they've written the formula here, tan theta is the listing moment over displacement times GM. Well, G to GH, the horizontal shift, is moments over weight. So that it's just written in a slightly different way, the formula. But it means the same thing. So the listing moment, you could have had listing moment over displacement and then divided that value by 0.53. Or do it like they've done here, and we get 12.2 degrees. Part B, we need to calculate the minimum GM prior to loading the boiler to limit the angle of heel to 10 degrees. Well, we can see here the angle is 12.2 degrees. So we need to find out what minimum GM we need prior to loading so that we can limit the angle to 10 degrees. Now, just to let us point one thing out here, at 8336 displacement, which is our initial displacement, the km is 9.71. Our initial kg is 9, therefore our initial GM on this vessel at the moment is 0.71, and at a GM of 0.71 we had an angle of list of 12.2. Okay, let's see if we can solve the problem. We know that tan theta is the listing moment over W times GM. We know the angle is going to be 10 degrees. We know the listing moment because it's going to occur, the maximum list is going to occur when the boiler is first picked up. So it's 16 times 60, which is 960. And we know the displacement, therefore we can find GM. So we know this value, we know that value, we know that value. Move the values around to get GM on its own, and we find the GM at the lift. This isn't the maximum GM, this is the GM at the lift is 0.65. So at 8396 displacement, our km is 9.68. That's what we found previously. Therefore the kg at the lift is 9.03. As in previous examples, we now go backwards if you like. That's where we are at the moment, holding the weight for a 10 degree angle of list, or heel, whatever you want to call it. Let's take the weight off at 30 meters kg. That gives us our initial kg. The km is 9.71 of course, so it means our initial GM is going to be 0.83. So we can see that initially, when we started the problem, we had a kg of 9 and the km was 9.71, so our initial GM was 0.71, and that gave us a list of our heel of 12.2 degrees. Once we've increased the GM to 0.83, when we pick the weight up, that will reduce our angle of heel to 10 degrees. So one thing you can see there, if your GM increases, then the angle of heel, when you pick the weight up, will decrease. And conversely, if your GM is less, then the angle of heel is going to increase when you pick the weight up. So what we're doing here, we're having to increase the GM to reduce the angle of heel. And of course, to increase the GM, we have to reduce the kg. And we can see there that on the first problem, our kg initially was 9. Now our kg prior to loading is going to be 8.88. So we're going to have to reduce that in order to get the correct GM at the start.